Okay, sorry about that, folks. Here we go. So the question still remains, whether you are blind or have sight. The lead coefficient here is 1, okay? And when we want to factor this trinomial, right, the strategy that we've been using is we take the lead coefficient and multiply it with the constant term, a times our c term, or the last number here, this constant term, okay? So it'll be 1, sorry, this one right here that's kind of understood to be there, right, times the negative 18, okay, which is just negative 18. Okay? So we need two numbers that multiply to negative 18 and then add to negative 7. Okay? Two numbers that multiply to negative 18 but that add to that negative 7. So let's just go through it, right? Okay? I could say 1 and negative 18. Right? I could say negative 1 and positive 18. Do either of those combos add to make negative 7? No. Nope. So I got to keep going. Let's see. How else can we multiply to get negative 18? 2 and negative 9. Does 2 plus negative 9 add to negative 7? Yes. Yes, it does. Okay, so we can say then x squared plus 2x minus 9x minus 18. So again, we take that middle term, the negative 7, okay, and we break it up using these two numbers. Okay? Because that's exactly what makes them up, right? 2x plus negative 9x, or 2x minus 9x, they add up to make that negative 7x there, right? So I'm not changing this, and that this is still saying the same thing as this, right? The first step here, the problem we're given, it's saying the same thing as this rewritten step. But now I have 4 terms, and I can use factoring by grouping. So group the first 2, group the second 2. Okay? So Alex, from that first group there, what can we factor out?
From the first parentheses,
yep.
You could factor out an x.
An x, very good.
That's really it.
That's really it. You're really right. So if I take the x out, what's going to be left behind from the x squared? It'll just be x
plus 2.
Very good.
And then for the next one, we could factor out a 2. Well, actually, a 9.
A 9. And should I factor out a positive 9 or negative 9, you think, here?
That's a good question. Would it matter?
Would it matter?
I would say negative.
Negative 9?
It's the only one there.
So if you can look here, Alex, right? Remember, our ultimate goal is to factor by grouping, and we want to have, we're hoping that we get an x plus 2 here, and we're hoping that we have another x plus 2 over here, right, so we can take it out. If I need this to be positive and positive, and they're right now negative and negative, I probably want to factor out a negative 9 to then make them positive.
So all you got to do is...
So negative 9, and then what's going to be left behind from this if I take out a negative 9? An x?
Plus 2.
There it is. Oh, hey.
From there is you would do negative 9 plus x in parentheses, then x plus 2.
Yeah, and I'm going to put it in this order, x minus 9, but negative 9 plus x is still the same thing.
Refresh my memory. Oh, you just put a 1 in front of the x
Uh-huh.
to get that.
Mm-hmm.
Okay. Very smooth move.
Smooth move. Very smooth. Okay. All right, is this ringing a bell some, hopefully? Speaking of the bell just buzzing there. Okay, ringing a bell. Yes? No? Yes? Okay. I know, right? Ugh. All right, let's take a look here at... Let's try number 2 then. We'll just go over here to number 2. I'll try and leave out the number 1 so you can kind of use that to refer to. Okay, so again, the directions are to factor. Now, remember this AC method, that's not the only method that we have to factoring, right? We could also, for example, use GCF. But if you look at number 2, is there a greatest common factor to all 3 of these terms here? Is there something that divides all 3 terms? No. I mean, like the first 2 have a P, but 14 does not. And 5 and 14, well, there's not really any number that divides both of those except for 1, so that's not super helpful. Right, Alex and Dylan?
Yeah.
So when we get the directions to factor here, you want to think about all the different strategies Alex, like greatest common factor, right? But there is no greatest common factor for number 2, so we can throw that out. So we see, oh wait, it's a trinomial. We should try factoring by grouping. Okay, so let's go ahead and do that. So let's see here. The lead term, the lead coefficient, we'll say, is what here, Tyler? So what's the lead coefficient of this polynomial? Tyler L, sorry. Can you see it okay? Lead. That is the coefficient in front. Well, so is this the lead term here? Lead means in front, right? What's the term in front? P squared, right? What's the coefficient of P squared? What number can we put in front here? A 1. So the coefficient there, okay, Tyler, is 1. Whenever you don't have a variable, or whenever you don't have a coefficient, you can put a coefficient of 1 there. Okay, what's the coefficient of this term, Tyler? Okay, good. And then this term, I guess you could, well, that doesn't really have a coefficient. That's just a constant. Coefficients are in front of variables normally, and that doesn't have a variable. So you wouldn't really say it's a coefficient. Okay, all right. So Tyler, coefficient's 1. So we're going to multiply that 1 back here to the negative 14. Tyler, what's 1 times negative 14? Negative 14. So we get negative 14 there. Tyler, can you tell me 2 numbers that multiply to negative 14? 2 nice numbers. And so no fractions or anything like that. 2 integers. Negative 2 times what? Negative 2 times negative 6? Nope, that gives us positive 12. What times negative 2 is going to give us negative 14? 7. Okay. Is that the right combination of numbers that we want? Yes. Ooh, it's close. It's not exactly right, though. What are we supposed to add to? Oh, negative 5. What does this add to? Positive 5. So, right, if we make this positive 2, though, and this negative 7, does 2 times negative 7 still multiply to negative 14? Yes. Does it add to negative 5? Yes. So this is the combination we want. Okay, that's the combination we want there. So p squared plus 2p minus 7p minus 14. Okay, so this little strategy that we're using here, is the only reason why we use it is to break up this middle term in a tricky way or in a strategic way so that we can now factor by grouping. Okay, that's the only reason why we use this thing. So again, your lead coefficient times your constant, and then look for 2 numbers that multiply to that product there, this negative 14, but then add to negative 5. Okay, and so now we'll factor by grouping. Okay, so I'll let you off the hook now, Tyler. Dylan, from this first group, what can we factor out?
First group,
P. And what's going to be left behind?
2, negative 5.
If I divide a p out of p squared, what's going to be left?
Squared, p squared.
Nope.
1 squared.
It's p. Because p squared, remember, what does that mean, Dylan? It means p times p. So when I divide a p squared out, right now I've got, let me see if I can do this. I'll put it up here. When I have p squared plus 2p, that's the same as p times p plus 2p. Right? And so when I remove a p, when I take a p out of here, I have a p left. I take the p out of this, I'm left with just 2. Okay? So dividing a p squared divide a p out of p squared, these are just p. And then divide a p out of this, Dylan, out of 2p, what's left now?
2.
Just 2. That's right. Okay? What about here, Dylan? What can I factor out of here? I got a negative 7. Very good. So minus 7. And if I take a negative 7 out of this, what's going to be left? P. And what about negative 14 divided by negative 7? What's that?
Negative 2 minus 2.
Positive 2. Because it's negative 14 divided by negative 7. So it becomes positive 2. Okay? Is factoring by grouping going to be helpful here? Do we get what we want? We got p plus 2 and a p plus 2 there, right? So that's right, Carson. We did get what we want there, okay? That's right. So we'll take out the p plus 2 in common here. Okay, take out that p plus 2 in common. And then Shepherd, when I take the p plus 2 from this term, what's going to be left behind?
The p.
Just the p. And when I take the p plus 2 out of this term, what's going to be left behind, Shepherd?
-7.
Yeah, -7. And so there, I took the p plus 2 out front, and then what's left behind is the p and the -7. And so that's our factored form. Sorry, I didn't circle that very neatly, but there it is. Okay? Let's get down to number 8. Okay, let's skip down to number 8, and then I want to also talk about number 6 as well. Okay, so let's skip down to number 8, and then we'll talk about number 6 here in a second too. Okay, number 8. All right, we want to factor this. So is there Mat S? Is there a GCF here for us to factor out? Is there something that I can divide all 3 of these terms by?
Did you say it?
Sure. So you'll see this is a trinomial, right? It has 1, 2, 3 terms. Okay. Is there a greatest common factor? That is there something I can divide each one of these terms by? No, that's right. There isn't. Okay. So we don't want to use GCF. Let's try and factor it by grouping though. So we have to use that product and sum. So what's our lead coefficient here in this problem? 2. Yep, there it is. And we're going to multiply that back with the what? 2 times the 21. Remember that? Okay, it's 2 times in the constant term. So 2 times 21, that's going to give us 42. Question, Sky?
Can we do number 7 next?
Sure, we can do that, yes. Oof, yeah, okay. All right, so let's take a look here. So how can I multiply to a positive 42? Well, I can do 1 and 42, but that's not right because it doesn't give me 17 when I add them, so no. Let's see here. I can do 2 and, let's see here, 42 divided by 2 is 21. Does that add to 17? No. Let's try 3. Does 42 divide by 3?
Not even.
It does. It's 3 and 14. Does that add to 17?
Yes.
Yes. So there's our combination right there. So we have 2b squared plus 3b plus 14b plus 21. So you can see there I took that 17b and I broke it up into 2 terms that would combine back together to give us a 17b. But again, we break them up so we can now factor by grouping. Okay. So, Catherine, from this first group, what can we factor out? What's a common factor in that first group? Does 3 divide by 2? Well, my point is, can you divide 3 by 2? No. Not evenly, right? It gives us a fraction. So we don't want to take a 2 out. But what is in common to both terms here? A 1? Okay, we could divide both by 1. Look, what else is in common, though? Because a 1, we can divide everything by 1. So what else is in common? What do both of these terms have? A b, yeah. A, b, 1b. So we're going to take a b out. If I take b from this, it's going to be 2b. So no longer b squared, Catherine. It'll just be 2b. And Catherine, if I take the b out of this, what will be left behind? Just a 3. That's right. Good. Okay. Now, how about 14b and 21, Catherine? What can we divide 14 and 21 by? Do you know? 21 divides by 3, but not 14. Anybody, what can we divide 14 and 21 by? 7. So we'll take a 7 out. 14 divided by 7 is 2b. 21 divided by 7 is 3. Okay, and again, we have 2b plus 3 in common there. So, Kendall, question? Let's hold off until we do number 6, and then, yes, I'll let you go, okay? Whoops. Unless it's an emergency? I'm guessing no. Okay. Okay, so we get 2b plus 3 times b plus 7. And again, we take out that 2b plus 3, or leave behind the b plus 7. Okay. Are we starting to remember this sum from before break?
Yeah.
Yeah? No? Not really? No? Kind of? Okay. All right. We did. Okay, all right, well, we'll do some more practice here. So one thing, so before we talk about skies, so we'll do skies on number 7 here in a second. I want to talk about number 6 here really quick, okay? So number 6, is number 6 a trinomial?
No.
It is not, right? It is, in fact, a what? Binomial, right? Okay, and we want to still factor this, okay? We want to factor this. So let's, again, go through our strategies here. Can we factor out a greatest common factor in this problem? Is there something in common to both terms we could divide out?
No.
Okay. Okay, exactly right. We can. So let's take that k out, and then what will be left behind here if we take a k out?
7K.
7k. And if we take a k out of 9k, again, dividing it out, we're left with just what? The 9. Is there anything else in common to these two terms that we can factor out? Is there anything else in common between the two terms? Can 7 and 9 both be divided by a number besides 1? No. So we're done. They're prime. They're relatively prime, we say. Okay? So that's the best we can do. It's not a trinomial, so we do not want to use this strategy that we did here. Right? The strategy we used for 1 and 2 and for 8, we do not want to use this strategy here for number 6, because number 6 only has 2 terms. Okay? This strategy that we're using for 1, 2, and 8 only works for helping us to factor trinomials. See? 3 terms, 3 terms, 3 terms. Here for number 6, it's only 2, so you don't want to use that same strategy. It's a different strategy. Okay, question? Let's go through one more problem here and then I'll let you go. Kendall, you can go, though, if you're ready to go. Okay, let's talk about number 7. Sky requested it. Okay? So, let's go here to Mark, actually. Mark, is there a greatest common factor to all 3 terms here? Is there something that we can divide all 3 of those terms by?
I'm looking. I don't believe so.
You're right. There isn't. So these 2 terms have an x, but this one doesn't. 7x squared and 28, both of those can be divided by 7, but unfortunately 45 cannot be divided by 7. So we're kind of stuck with these kind of larger numbers. All right, so we're going to factor this trinomial. So again, we're going to take that 7, and the 7 multiplies with what else? We're going to take our lead coefficient and multiply it with the negative 28. Okay, I'm going to have to do that my calculator here. So negative 196. Whew. I know, it's kind of big. Because we got to think of 2 numbers that multiply to 196, or negative 196, and add to negative 45. Okay, so we can try 1, right? So 1 and negative 196. And we could do negative 1 and positive 196. But Alex, are those the pair of numbers that we want? Do either of those work?
What?
To do 7 times negative 28 gives us negative 196. We're looking for 2 numbers that multiply to negative 196 but add to negative 45. So we started out, Liv was like, kind of joking, but this is not a bad place to start. I mean, the obvious 2 ways to multiply negative 196 is 1 times negative 196, negative 1 times 196. Do either of these add to that negative 45 that we need? Alex, I was talking to you the whole time, okay? So does
what number can you
this,
divide it into?
does this add to make this? It's an easy answer. Don't make it harder than it needs to be. Does 1 plus negative 196, does that add to negative 45? No. So these are not
So we have to
options. So we have to keep looking, right? So let's try 2. 196 is even, so I can divide it by 2, and we get 98. Of course, I need to have one of them be negative, so we'll say 2 and negative 98, or negative 2 and positive 98.
These do not add.
These do not add to negative 45.
So we have to do.
Okay, so we'll cross those
It's
out.
impossible to do 3.
Let's see. 196 divided by 3. No, it's not. Do you guys remember the?
Let's do 4.
Do you guys remember the divisibility rule for if something divides by 3? If you add all the digits, so 1 plus 9 is 10. 10 plus 6 is 16. If 16 does not divide by 3, then neither will 196. Did you know that? That's how you can check to see if something divides by 3. If you add the digits together and that sum is divisible by 3, then the number itself will be divisible by 3.
So if you add all the digits, does it equal?
If that number, the sum that you get by adding the digits, if that divides by 3, then the number itself divides by 3.
Okay. So if we were to do
So for example, if this was 195, if it was 195, 1 plus 9 is 10, plus 5 is 15. 15 does divide by 3, so 195 is divisible by 3. But 196
Now,
is
what if the number was higher than 16 and you can still divide it?
If you can still divide by 3, then the number itself divides by 3, regardless. Yeah. So question, Alan.
Doesn't it work like that for 9 too?
I think so. Yes. At least I know for like the 2 digits it works. I'm not sure about the rest of them, but it might. It might. Yeah.
There is a rule for 9. I can't
Yeah.
remember what it is.
It's helpful. So, but more importantly, right? We're just going to keep guessing and checking here. So obviously 3 doesn't work. What about 4? Let's see if 4 works. We can kind of see that 4 is going to work because 2 worked, and what we were left with was still even. So that means we can still divide by another 2, in other words. So we can divide by 4 here. So let's try 4. And we get negative 49 there. Okay. And does this add up to negative 45?
Yes.
Yes. So 7x squared plus 4x minus 49x minus 28. Okay, group the first 2, group the second 2. And hopefully from this point it should be pretty straightforward. Mark, from this group, Mark, is there anything, what's the greatest common factor we can take out here? Or what can we take out?
7, no 4x. Wait.
What do both of these have in common that we can take out?
Oh, an x.
An x. If I take an x out from 7x squared, what will be left now? 7
squared.
Nope, 7x. So it's, remember, x squared means you're doing x times x. There's 2 x's there, right, that were being multiplied together. So we take one of those x's out, we're left still with an x left behind, right? That makes sense?
Yeah.
Okay. Plus, and then we take the x out of here, what's left behind?
4.
Just the 4. Okay, what can we divide both negative 49 and negative 28 by?
7.
A negative 7, yeah, good. So for the positive 7, and then a minus 4, like that. Well, I factored, oh, you're right, thank you. Yes, it would be. And that's important, isn't it? Because if these don't match up, then you're done, right? You need to have your 2 simplest factors there match up. And so now we can factor out that 7x plus 4. And so, Mark, if I take the 7x plus 4 out, what's left from here?
Just the x.
Mm-hmm. And what's left from here?
The negative 7.
Mm-hmm. And so there's our final answer. Okay. So, Sky, was it just the bigger quantity that we had to deal with there? Is that what threw you off? Yeah. Okay. All right, so let's have you guys try numbers 3 and 5 real quick just to see that we're doing this okay. So try 3 and 5, please. Now you may go, yes. So go ahead and try 3 and 5, please. Number 3 and number 5. I have one more problem after this I want to show you. Okay, so get 3 and 5 done, and then I have one more problem I want to show you. What's that? I think, I'm not sure yet. We'll see. I'm not sure yet, but it'll be on this paper. And it'll be only from the circled problems too. So, okay. So go ahead and try 3 and 5, please. Just 1/2 of a problem for homework. You know what? Think about it. Okay, try 3 and 5. 3 and 5. Try 3 and 5. So try these 2 right here, okay? These 2 right here. 3 and 5. Alright. Do you want to go on this? Leave it Band-Aid for your feet. For the counselors.
What would that Band-Aid?
Your brain.
Your forehead.
For your heart.
Would they like do surgery for the
Probably, yeah. It's pretty intrusive. Do you want to do that?
Yeah, I might have to sit there.
Let's try 3 and 5. Try 3 and 5. So, to multiply the positive 8, you do the positive 1 times the positive 8, or negative 1 times negative 8.
help me. You're just looking at my paper.
Alright guys, I'll come over and help.
Wait,
Can I do my
3
work
and
with
what?
a copy?
3 and 5.
5?
I did 3.
Okay, so. Are you looking at 5 right now?
I was basically trying to quote unquote help. He's not. He's like, this is him.
Yeah, we'll see.
I tried to.
I mean,
He knows that Sean out here, that way you guys can see who's picking them.
no,
I
it's
was
I was
showing her.
I was thinking like,
No, I wasn't. I was like, no. She doesn't teach.
yeah.
We'll think about that. I will think about that.
I mean, he was like, I mean, this is like, he has to be able to what?
Yeah, pretty much. And then, you know, yeah, pretty soon.
I saw this thing about this one. It's like the world did it in 2012. Every day. I just felt like it has gone by so fast. But I can actually connect. It has gone by so fast. It also said that in real stories they said Luke got your father. Now it's like no Luke got your father. And then you know some people said that he's alive. A lot of people thought he was dead and he's actually still alive. And then like there's someone yeah.
Did you see the video? Is this are you talking about the same video where she's shirt and then she's
Bucky's face is like shut up. Can you believe it?
I feel bad for saying that, but it's bad. Everyone's like, oh my gosh, she's so cute.
Have you ever
She doesn't have I know that. She made me really close. Yeah, you did.
I guess it depends on how you find it.
What do you think?
And you have an app.
Yes.
So, you're looking at number 5 or 3? 7 times negative 20. So for 2 numbers, do you have a calculator?
Watch that.
And look for pairs of numbers, multiply them by 1 add negative 34. Okay? Yeah, you're done. Now get it out. That'll help you out. Okay?
I'm not done.
Don't forget to continue to factor by your routine. So another thing I'll also point out here is that negative 1 times 8 does not multiply to 8. It multiplies to negative 8. If you think of, again, the number you're looking for here, you need 1 times 8 to get a positive 8. So you need 2 numbers that multiply to positive 8, but that adds to negative 9. Okay, so that's what you're looking for.
So, after the cops, I was in, my mom was in all the time, so I'm listening to me, how bad my friend was, and how I was like crying. And then the cops went to her and said they switched the story. Like, the parent,
Nailing it.
to get me in trouble. So I'm like, I'm probably not going to this. Because once the mom showed them the text, they were like, and then back when they were like, I heard anyone else. Oh, she's my next door. Definitely not. Next door. He's not close my house.
Erica, this boy does not know what it is. He's like a little troll.
It's in the middle. That's why they call it.
It's like,
Exactly.
Mini is so funny. It's blue and blue one, the little circle around the whole field. It takes
Maybe that's what they do it for girls lacrosse.
yeah.
Not actually.
Next door neighbor. Where is she? Where's she from? Wait.
Me and the guy.
I won't be going to school with anybody next year.
I got negative 5.
I'm either doing online
Like,
or
the other thing is, guys have more positions that are way cooler. Like,
I might do it.
mini, and I'm mini. C. It's like
I'm
mini
gonna do it at 1. I did 5 times. Like 5 about
But I'm a level 8 mini.
So I might. Which one are you doing? 5?
Okay, folks. Yep. Let's take a look here. Number 3 first. Number 3 first. We'll look at number 5. Okay. All righty. Come on, man. Listen up, folks. Eyes up front. Shh. Dylan, Alex, gentlemen. Shh. All right, let's go to Ben. All right, so Ben, m squared minus 9m plus 8. We're looking to factor this thing. Is there a greatest common factor to all 3 terms here, Ben? Can we divide?
All 3?
Yeah. Is there any one thing that divides all 3 simultaneously?
1.
Yeah, just 1, right? And that's about all we can do. So in other words, dividing by 1 is pretty much like saying there's no other greatest common factor besides 1, so there's nothing to take out. So we're done with that, okay? Now we're going to try and factor it because it's a trinomial. So we're going to see if we can factor it by using that strategy we use where we take the lead term here, 1, multiply it back with the 8, and 1 times 8 is 8, right? And now, Ben, we need 2 numbers that multiply to 8 but add to make what? What? Make what?
Negative 9.
Negative 9, yeah. Okay, so Ben, give me 2 numbers that multiply to make 8.
2 and 4.
2 and 4. Are they going to add to make negative 9? No. Okay, what else? What are the other 2 numbers?
8 and 1.
8 and 1. Ah, yes. 8 plus 1. Did they add it to make negative 9?
Negative 1. 8 and negative 1.
Okay, but then if I do 8 and negative 1, does that multiply to make positive 8?
They both of them need to be negative.
Ah, very good, Ben. Awesome. Very good. Mark and Alex and Dylan. Guys, you guys just missed it. You missed it. You missed it. Okay? I'm going to say it again, but you still missed it. Okay? Shh. Again, we're trying to multiply to make 8 here. Okay? Now, this is a bit of a strange problem because we have a positive number that we're multiplying to, but we're supposed to add to a negative number. Okay? That's weird. We multiply to a positive number. We are supposed to add to a negative number. The only way to do that is if you use 2 negative numbers, like Ben figured out here, negative 8 and negative 1. Okay? That then breaks apart that middle term.
Wait, why are we doing 8? 9.
8 is 1 times 8, right? You take the lead term here times 8 gives you 8. And then you want to add to the middle term, Sean. So you multiply the first and the last term, or first and last coefficients kind of thing, the first and last numbers, lead coefficient and the constant. 8. And then 2 numbers that multiply to 8, but then add to negative 9. That's negative 8 minus 1. So group and group. What can we take out from that first group there, Ben?
The exponent.
Well, not the exponent. No, what's in common to both?
Negative 8 then.
Nope, only that's got a negative 8. This one doesn't have a negative 8. What divides both of these terms? An m. And if I take an m out of m squared, I'm left with just m. Okay, take the m out of minus 8m, I'm left with minus 8. What about here? What can we take out here?
M again.
So does this have an m now?
No.
No, it doesn't. So there's nothing really, except if I look here, I've got negative m plus 8, and I need to have m minus 8. So I'm going to take a negative 1 out here. You see how that works out now? Now we get the same thing. M minus 8, m minus 8. Okay. Was that stumping you?
I was like, no, I have it now, but I was
Yeah. You can see here, right, we had m minus 8. And all these factor my groupings, if we're going to get it to factor, we need the same thing over here. And you can see, well, negative 1m plus 8, that's almost positive m minus 8. They're just opposites. So we take a negative 1 out. We factor out a negative 1 here to make that m positive. And now you can see we have the exact same thing. So we're left with m minus 8 times m minus 1. And there's our answer. Okay? All right, number 5.
Did we do 5? Oh, we did.
Yep, 3 and 5. Tyler C. Mr. Wid.
Yes.
7 gets multiplied with
31.
eh.
Oh, okay.
Lead coefficient, right?
Yeah.
Times negative 20, the last term. negative 140. Okay, that's what we're shooting for there. Again, you can look at this and see, is there a GCF? Is there one number, Tyler, that divides all three of these things, or one variable that divides all three of these things?
I would say
Like, for example, this first one, I can divide it by 7, right? But does 31 divide by 7, or does 20 divide by 7? No. And these first two, they both have an x, but the third one doesn't. So there's no common factor. There's nothing shared by all three. And so we have to go to this factoring by like a trinomial strategy here. So we're going to take that 7 times negative 20, and we get negative 140. Okay? And so, Tyler, we're looking for two numbers that multiply to this, but that add to what?
20.
Nope. Negative 31, the middle term there. Okay? So let's just pick some easy ones. Let's try like 1 and negative 140, or let's try negative 1 and positive 140. But are either of these going to add up to negative 31? No. All right, let's try 2 and negative 70. And negative 2 and positive 70, are they going to add to negative 31? No. All right, let's see. Does 3 work? 3 is not going to work. Let's try 4. 4 and 35? Negative 35? Or negative 4 and positive 35 could work too. Do either of those add to negative 31? Yes, this one does. Okay, so 7x squared plus 4x minus 35x minus 20. Okay, group. Okay, Tyler, from that first group, what can we take out?
We can take out the x's.
An
Wait, why
x.
is 35 then? Oh, wait, never mind.
You're good? Okay. What can we take? And then what's left behind if I do that, Tyler?
7x and 4.
Very good. And then from here, what can we take out?
We can take out negative 5.
Good. And good. Negative 5. Very good. 7x plus 4. Okay. So then we take out that 7x plus 4 that's in common to both. And then there's your answer. 7x plus 4 times x minus 5.
Tom.
Okay, question?
Okay, I had a question about number 3, so I just didn't ask it. Anyway, so
Well, thank you for asking it now.
I got like the same answer, but instead of getting like the matching of m minus 8, I got the matching of m minus 4.
So that's fine. I'm assuming you flip the order here. You have minus 1m minus 8m minus plus 8.
Same.
Yeah, so that's fine, right? That's okay, right? That's okay because isn't m minus 8 times m minus 1, isn't that the same as saying m minus 1 times m minus 8?
Yeah.
3 times 2 is the same as 2 times 3, right? So multiplication, that's the commutative property. You can flip the order of multiplication. It's still okay. So good. Thank you for asking that clarification. All right, I got one more problem I want to do together here. Let's just take a look at it. And I think, I think it's number 14 is the one I want to look at. So let's skip over to 14 real quick. Time flies when you're having fun, Reagan. Why are you laughing? Just more fun. Just more fun. It's more fun.
She's trying to get it.
I'm sorry. Why did I ask? Of course. It's fun. It's so fun. All right. Okay. Anyway, is there a GCF here we can factor out? Anybody? No. Okay. 9 and 5 and 10, they don't have anything in common we can divide out. These have R's, but this doesn't, so no. So we'll have to do the factor by grouping. So we'll do 9 times negative 10, negative 90. We're looking for two numbers that multiply to negative 90 but add to negative 5. So that's going to be 1 and negative 90 or negative 1 and positive 90. Nope, those don't work. We could do 2 and negative 45 or negative 2 and positive 45. Do either of those add to negative 5? Nope. All right, let's try 3 and negative 30 or negative 3 and positive 30. Do either of those add to negative 5? No. Oy vey. All right, let's keep going here. Let's try 4. What is that? Negative. So 4 and negative 15 or negative 4 and positive 15. Do either of those add to negative 5? No. Let's see here. 5. Let's try 5. 5 and negative 18 or negative 5 and positive 18. Do either of those add to negative 5? No. Okay, let's keep going. Let's see. 6. No, 90 doesn't divide by 6. Nor 7, nor 8. But 9 and negative 10 or negative 9 and positive 10. Do either of these add to make negative 5? No. And at this point now, if I keep going, I'm just going to get to 10, but I already have the 10 pair. I have 10 and 9 and 10, negative 9, negative 10 and 9. And I could keep going. The next one would be 15 and 4. But again, it's not going to work. Wait a minute. I did 15 and 4. Sorry, it should be 15 and... Hang on a second. I didn't do this right. 15 and 6. Thank you. Negative 6 and 6 there. Sorry about that. Thank you. Sorry. But still, does 6 and negative 15 or negative 6 and 15, does that work? No, it doesn't. So my point is we've got all of our pairs here and nothing works. So what do we say?
Undefined.
Not undefined.
Defined.
Doesn't factor. Okay? You could also use the word, well. I'll just say that. Thank you. Excuse me. So, that's frustrating, isn't it? Because now we have this, this option where it might not factor at all, okay? Which is possible. Now, 99% of the problems we're going to do will factor. So if you're doing homework and you just say, all 5 of them don't factor, you're wrong, okay? So you need to go back and check your work. Speaking of homework, I'm going to have you do number 4, 9, and 16. 4, 9, 16. Sorry, Matt. 4, 9, and 16. What's that? I understand. 4, 9, and 16 from the worksheet, please. Just 3. 4, 9, and 16. Now, I'll give you a hint. One of these 3 does not factor. One of these 3 does not factor. Good time. You'll be able to figure it out, Bill. Well, I have faith in you. Okay? Any set requests for tomorrow?